Now, we need to count on in hundreds. So first, we have 19,566, 19,666, and 19,766. So what are the next 7 numbers in this sequence? Well, if we show them, we can see that counting on in hundreds is just like counting on in ones, but with our tens and ones digits staying the same. And that's because we're adding 100 each time. So now we have 199,355, 199,455, and 199,555. If we show the next 7 numbers in the sequence, again, we can see that counting on in hundreds is just like counting on in ones. So if we were counting in ones, after 1,999, we would have 2,000. And that's why, when we're counting in hundreds, after 199,955, we have 200,055. Now we can show place value counters to represent our counting. So we start with 19,566. So in that number, we have 1 10,000, 9 thousands, 5 hundreds, 6 tens, and 6 ones. We're counting in hundreds, so we start with 5 hundreds, but we can add hundred counters, so we have 6, 7, 8, 9, and then when we have 10 hundreds, because we can only have one digit in each place value, what we need to do is exchange our 10 hundreds for 1,000, because 10 hundreds has the same value as 1,000. But now that we've made our extra 1,000, we have 10,000 counters. So we need to exchange these 10,000 counters for one 10,000 counter. And that's why we have 20,066, because we have 2 10,000s, no thousands, no hundreds, and we still have our 6 tens and 6 ones. So then we can keep on adding hundred counters until we get to 20,466. Then we started with 199,355. So that's 100,000, 9 10,000s, 9 thousands, 3 hundreds, 5 tens, and 5 ones. We're counting in hundreds, so we can add hundreds counters each time. But then, when we get to 10 hundreds, we have the number 200,055. That's because we can exchange our 10 hundreds for 1,000. But now we have 10,000s, so we can exchange those 10,000s for 1 10,000. And now, because we have 10 10,000s, we need to exchange those for another 100,000 counter. So that's why we have 200,055. And then we can keep counting in hundreds until we get to 200,255. Now for these questions, we need to add a multiple of 100, so a number that ends in 2 zeros. And we can answer questions like this mentally, without needing to use column addition. So first, we have 8,241 plus 700. If we highlight the hundreds digits in our question, we start with 2 hundreds and we're adding 7 hundreds. So we'll have 9 hundreds in our answer, and all of our other digits will stay the same. So that's 8,941. Now we have 27,553 plus 800. Now here, if we highlight our hundreds digits, we have 5 plus 8, but that comes to 13, which is a 2-digit number, and we can only have 1 digit in each place value. So what we need to do is to highlight our thousands digit as well. So highlight the place value column to the left. Then we have 75 plus 8. That comes to 83. So instead of the 7 and the 5, we'll have an 8 and a 3 for 83. And all of our other digits that we've not highlighted will stay the same. So that's 28,353. Now 289,931 plus 400. If we highlight our hundreds digits, 9 plus 4 is 13, but that's a 2-digit number. So we need to go to the left and highlight our thousands digit as well. But now we have 99 plus 4. That's 103, but that's a 3-digit number, and we only have 2 digits highlighted. So we need to go to the left again and highlight our 10,000s digit as well. That means we have 899 plus 4. That's 903, so we're going to have a 9, a 0 and a 3 instead of these digits that we've highlighted. Our other digits will stay the same, so we get 290,331. 399,555 plus 700. If we highlight our hundreds digits, we have 5 plus 7, but that gives us 12, a 2-digit answer. So we go to the left and we have 95 plus 7. But that gives us 102, which is a 3-digit answer, and we've only highlighted 2 digits. If we go to the left again, we have 995 plus 7, but that's 1002, so a 4-digit answer, and we only have 3 digits highlighted. So here we need to go all the way over to our 100,000s place value and add 3,995 plus 7. That's 4,002. So these digits here will be replaced with a 4, a 0, a 0 and a 2. Our other digits in our tens and ones stay the same, so our answer is 400,255. So now let's show place value counters to represent the additions that we've done. For this first question, we started with 8,241. So that's 8,000s, 200s, 4 tens and 1 1. We were adding 700, so if we add 1, 2, 3, 4, 5, 6, 700s, you can see that we now have 8,000s, 900s, 4 tens and 1 1. So that's 8,941. Then we had 27,553, so that's 2 10,000s, 7,000s, 500s, 5 tens and 3 1s. We were adding 800, but remember, when we get 10 hundreds, we need to exchange those for another 1,000. So we can add 1, 2, 3, 4, 5, 6, 7, 8 hundreds, and you can see that once we got to 10 hundreds, we needed to exchange for another 1,000. So now we have 8,000s counters and 300s, so that's why we got 83 in the digits that we'd highlighted. Then we had 289,931, so that's 200,000s, 8 10,000s, 9,000s, 900s, 3 tens and 1 1. We needed to add 400, but we already had 900s, so when we added 100, we could exchange that for 1,000, but then doing that gives us 10,000s, so we need to exchange those for one more 10,000, and that was just adding 100, so we need to add 200, 300, 400, and when we've done that, we get 290,331 because we have 200,000s, 9 10,000s, no thousands, 300s, 3 tens and 1 1. Then our last question was 399,555. So that's 300,000s, 9 10,000s, 9,000s, 5 hundreds, 5 tens, and 5 ones. We needed to add 700. We could add 1, 2, 3, 4, 5 hundreds, but adding 5 hundreds means we've got 10 hundreds altogether. So we exchange those for 1,000, but then we can exchange 10 thousands for 1 10,000, and we can exchange 10 10,000s for 100,000 counter. So that was adding 500, so to add 700, we need to show 2 more hundreds. That gives us 400,255 because we have 400,000s, no 10,000s, no thousands, 200s, and we still have our 5 tens and 5 ones. Now we need to count on in thousands. First, we have 92,522, 93,522, then 94,522. So what are the next 7 numbers in this sequence? Well, if we show them, we can see that counting on in thousands is just like counting on in ones, but with our hundreds, tens, and ones digits staying the same because we're counting on 1,000 each time. Now we have 792,322, 793,322, and 794,322. If we show the next numbers, again we can see that counting on in thousands is just like counting on in ones. So if we were counting in ones, after 799 we would have 800, and that's why when we're counting in thousands, after 799,322 we have 800,322. So we can show place value counters to represent what we've counted. We started with this first question with 92,522. So that's 9 10,000s, 2,000s, 500s, 2 tens, and 2 ones. We were counting in thousands, so we can add 1,000 counter each time. But then, when we get 10,000 counters, we need to exchange those 10 counters for 1 10,000 counter. But now we have 10 10,000 counters, and we can exchange those for 100,000 counter. So then we end up with 101,522 because we have 100,000 counter, no 10,000 counters, 1,000, and we still have our 500s, 2 tens, and 2 ones. Then we started with 792,322. So that's 700,000s, 9 10,000s, 2,000s, 300s, 2 tens, and 2 ones. We were counting in thousands, so if we add another 1,000 counter each time, when we get 10,000 counters, we need to exchange those for 1 10,000 counter. But now, because we have 10 10,000 counters, we need to exchange those for another 100,000 counter. So then we end up with 801,322 because we now have 800,000s, no 10,000s, 1,000, and we still have 300s, 2 tens, and 2 ones. Now we need to add a multiple of 1,000, so a number that ends in 3 zeros. And we can work out our answers without having to use column addition. First, we have 14,824 plus 6,000. Now if we highlight our thousands digits, we have 4 and 6, but that makes 10, and 10 is a 2-digit number, and we can only have 1 digit in each place value. So what we need to do here is to highlight our 10,000s digit as well. Now 14 plus 6 is 20, so we can replace the digits we've highlighted with a 2 and a 0 for 20. All of our other digits that we've not highlighted stay the same, so our answer is 20,824. Now 94,600 plus 6,000. If we highlight our thousands digits, again we have 4 plus 6, but that's 10, a 2-digit number. So let's highlight our 10,000s digit as well. 94 plus 6 is 100. That's a 3-digit number, and we only have 2 digits highlighted, but that doesn't matter because we don't have any more digits to the left. So instead of 94, we can write our answer as 100 followed by the 600, so 100,600. That's because 94 plus 6 is 100, and then the digits that we've not highlighted, so the digits in our hundreds, tens and ones, stay the same. We have 383,695 plus 8,000. If we highlight our thousands digits, 3 plus 8 is 11. That's a 2-digit number, so we need to highlight the digit to the left as well. So now 83 plus 8 is 91. So instead of an 8 and then a 3, we can replace these digits with a 9 and a 1, because 83 plus 8 is 91. All of our other digits will stay the same, so our answer is 391,695. Now 299,915 plus 9,000. If we highlight our thousands digits, we have 9 plus 9, which is 18, but that's a 2-digit number. So we go to the left and we have 99 plus 9. But that's 108, and that's a 3-digit number. We only have 2 digits highlighted, so we need to go to the left again and work out 299 plus 9. That's 308, so we can replace these digits with a 3, a 0 and an 8 and leave our other digits the same. So that gives us 308,915. Now let's have another look at this first question, and this time let's use place value counters to show the addition. We started with 14,824, so that's 1 10,000, 4 thousands, 8 hundreds, 2 tens and 4 ones. We were adding 6,000, so if we add another 6,000 counters, we now have 10,000 counters, but we need to exchange those 10 for another 10,000 counter. And that's why in our answer we have 20,824, because we now have 2 10,000 counters and no 1,000 counters. And then of course our hundreds, tens and ones have stayed the same. Then we had 94,600, so that's 9 10,000s, 4 thousands and 600s. Let's add 6,000. If we add 1, 2, 3, 4, 5, 6,000 counters, we now have 10,000 counters. But because we can only have one digit in each place value, we need to exchange those 10,000 counters for one 10,000 counter. But now, because we've done that, we have 10 10,000 counters. So we need to exchange those for 100,000 counter. And that's why our answer is 100,600. So now let's look at 383,695. We have 300,000s, 8 10,000s, 3,000s, 600s, 9 tens and 5 ones. We need to add 8,000, but when we do that, we're going to need to regroup when we get to 10,000s. So we can add 1, 2, 3, 4, 5, 6, 7, 8,000 counters, And then, because we needed to exchange, we now have 9 10,000 counters and 1 1,000 counter. So that's why we have the 91 in the digits that we've highlighted here. Now our last question was 299,915. We've shown this here, and we were adding 9,000. But when we add just one more 1,000, we have 10,000 counters. So we exchange those for one 10,000 counter. But now, because we've done that, we have 10 10,000 counters, which can be exchanged for one more 100,000 counter. So that was just adding 1,000. So we need to add 8 more thousands. And that gives us 3 100,000s, no 10,000s, and 8,000s. So that's why we have 308 in the digits that we've highlighted, because of course our hundreds, tens, and ones have stayed the same. Now we need to count in steps of 10,000. So first we have 79,500, 89,500, then 99,500. So what are the next 7 numbers in this sequence? Well, if we show them, we can see that counting in steps of 10,000 is just like counting in ones, but with the thousands, hundreds, tens, and ones digits staying the same, because we're adding 1 10,000 each time. Now, 465,000, 475,000, 485,000. If we show the next 7 numbers, again we can see that we're really just counting in ones, but then leaving our thousands, hundreds, tens, and ones digits the same, because we're adding 1 10,000 each time. So if we look back to this first sequence, we started with 79,500. So that's 7 10,000s, 9,000s, and 500s. We were counting in steps of 10,000. So if we add 10,000 counters each time, once we've got 10 10,000 counters, we need to exchange those for 100,000 counter, because we can only have one digit in each place value. So now we can keep on adding 10,000s until we get to 169,500. So that's 100,000, 6 10,000s, 9,000s, and 500s, because of course the thousands and the hundreds stay the same because we're counting in 10,000s. Then we started with 465,000, so that's 400,000s, 6 10,000s, and 5,000s. We were counting in 10,000s, so let's add 10,000 counters each time. You can see that once we've got 10 10,000 counters, we need to exchange those for 100,000 counter. So then, if we keep on adding 10,000s, we get 555,000. So 500,000s, 5 10,000s, and of course we still have our 5,000s. Now we need to add a multiple of 10,000, so a number that ends in 4 zeros. And we can do this using our knowledge of place value, so without needing to use column addition. First, we have 65,000 plus 40,000. If we highlight our 10,000s digit, we have 6 plus 4, which is 10, and though that's a 2-digit number, because we don't have any more place values or any more digits to the left, we can just replace this 6 with a 10 and then leave the remaining digits the same. So our answer is 105,000 because we're changing the digits that we've highlighted, and then our thousands, hundreds, tens, and ones digits will stay the same. Now we have 395,000 plus 30,000. Again, we can highlight our 10,000s digits. We have a 9 and a 3, but that makes 12, which is a 2-digit number, and we can only have one digit in each place value. So what we need to do here is to highlight the digits to the left as well. So highlight both our 100,000s and our 10,000s digits. Then we have 39 plus 3. That's 42. So we're going to replace these digits with a 4 and a 2. All of our other digits stay the same. So our answer is 425,000. Now we have 284,500 plus 50,000. Again, we can highlight our 10,000s digits. We have an 8 and a 5. But again, that gives us 13, which is a 2-digit number. So what we need to do, just like we did before, is highlight our 100,000s digit as well. So now, in the digits that we've highlighted, we have 28 plus 5. That's 33. So we're going to replace the 2 and the 8 with 2 3s. Our other digits will stay the same. So we have 334,500. Now to see why this method works, let's look back to this first questions and let's use place value counters to represent what we did. So we started with 65,000. That's 6 10,000s and 5,000s. We were adding 40,000s, which is 4 10,000s. So if we add 1, 2, 3, 4 10,000 counters, we now have 10 10,000 counters. But because we can only have one digit in each place value, we can exchange 10 10,000s for 100,000. So that's why our answer is 105,000, because we have 100,000 and we still have our 5,000s. Then we had 395,000, so that's 300,000s, 9 10,000s and 5,000s. We were adding 30,000, which is 3 10,000s. But if we add just one more 10,000, we now have 10 10,000s, so we need to exchange those for another 100,000 before adding 2 more 10,000s, so that we've added 3 10,000 counters altogether. So now you can see that we have 4 100,000s and 2 10,000s. The 5,000 stayed the same, so we have 425,000. So that's why when we were adding a multiple of 10,000, we needed to change both the 10,000s and the 100,000s digits. So our last question was 284,500 plus 50,000. So we have 200,000s, 8 10,000s, 4,000s and 500s. If we add 2 more 10,000s, that gives us 10 10,000s, which we need to exchange for 100,000. So we've added 2 10,000s, but we needed to add 5. So if we add 3 more, we now have 3 100,000s and 3 10,000s. So that's why both the 100,000s and the 10,000s digits changed. Of course, we still have our 4,000s and our 500s. So our answer is 334,500. Now we need to add a multiple of 100,000, so a number that ends in 5 zeros. First, we have 49,500 plus 300,000. So in this first number, we don't have a digit for our 100,000s. So all we need to do is write 3 in the 100,000s place and then leave all of our other digits the same. So our answer is 349,500. Now we have 230,000 plus 700,000. We can highlight our 100,000s digits, and we have 2 plus 7, so we're going to have 9 in our 100,000s, and all of our other digits will stay the same, so that's 930,000. Now we have 284,500 plus 200,000. If we highlight our 100,000s digits, 2 plus 2 is 4, and all of our other digits will stay the same, so we have 484,500. We can show what we did using place value counters. So for this first question, we started with 49,500. So that's 4 10,000s, 9,000s, and 500s. We were adding 300,000. So if we add 300,000 counters, that gives us our answer, 349,500. Then we had 230,000. So that's 200,000s and 3 10,000s, and we were adding 700,000. So if we add 700,000 counters, you can see that we now have 900,000s and 3 10,000s, so that's 930,000. Then we had 284,500, so that's 200,000s, 8 10,000s, 4,000s, and 500s. We were adding 200,000, so if we add 200,000 counters, you can see that we now have 484,500. Now we need to add using column addition. First we have 9,681 plus 5,562. We start by adding the smallest place values first, so we start on the right. 1 plus 2 is 3, 8 plus 6 is 14, but that's a 2-digit number, so we need to write 14 as 1 4. 1 plus 6 plus 5 is 12, so that's 1 2, and then 1 plus 9 plus 5 is 15. Our answer is 15,243. Now we have 95,435 plus 90,988. Again, we start on the right. 5 plus 8 is 13, so 1 3. 1 plus 3 plus 8 is 12, that's 1 2. 1 plus 4 plus 9 is 14, so 1 4. 1 plus 5 plus 0 is 6, and 9 plus 9 is 18. So our answer is 186,423. Now we have 833,560 plus 67,650. So because we're adding whole numbers, we need to make sure that the numbers are written out with the digits lined up on the right hand side. Because if we do that, then the place values in the question, so our ones, tens, hundreds, thousands, 10,000s, and 100,000s will be lined up as well. 0 plus 0 is 0, 6 plus 5 is 11, that's 1 1. 1 plus 5 plus 6 is 12, so 1 2. 1 plus 3 plus 7 is 11, so 1 1. 1 plus 3 plus 6 is 10, that's 1 0, and 1 plus 8 plus nothing is 9. Our answer is 901,210. Now we have 572,749 plus 231,758. 9 plus 8 is 17, so 1 7. 1 plus 4 plus 5 is 10, that's 1 0. 1 plus 7 plus 7 is 15, so 1 5. 1 plus 2 plus 1 is 4, 7 plus 3 is 10, so 1 0, and 1 plus 5 plus 2 is 8. That gives us 804,507. Now to see why this method works, so why, if we get a 2-digit number, we need to write the first digit above the next place value column along, we can show these additions using place value counters. So first, we started with 9,681. So that's 9,000s, 600s, 8 10s, and 1 1. We start by adding the smaller place values, so first we added 2 1s. to get 3 ones, but then we needed to add 6 tens. Remember, when we have 10 of any place value counter, we exchange it for 1 of the place value to the left. So 10 tens are exchanged for 100. So if we add 6 tens, we can add 1, 2, then exchange, then add 3, 4, 5, 6. So because we made 1 extra 100, we write 1 above our hundreds column, and then that leaves us with 4 tens, which we can write in our answer. So now we need to add the 100 that we made from adding our tens to the 600s that we started with, and we need to add another 500s. Remember, again, when we get to 10 hundreds, we need to exchange those for 1 extra 1,000. So we can add 1, 2, 3 hundreds, then exchange, then add 4 500s. So that means that we've made 1 extra 1,000, which we write above our thousands place value column, and we have 2 hundreds. So that's why we have a 2 as the hundreds digit of our answer. So now we need to add the 1,000 that we made from adding our hundreds to the 9,000s in our question, and we need to add 5 more thousands. Now we already have 10,000s because 1 plus 9 is 10. So we can do the exchanging first and exchange 10 thousands for 1 10,000. Then we need to add 5 more thousands, and that gives us our answer 15,243, because we have 1 10,000, 5 thousands, 2 hundreds, 4 tens, and 3 ones. Next, we had 95,435, so that's 9 10,000s, 5 thousands, 4 hundreds, 3 tens, and 5 ones. We started by adding 8 ones, so we can add 1, 2, 3, 4, 5, then exchange, then add 6, 7, 8. So we write the 110 that we've made above our tens column and the 3 ones that we now have in our answer. So now, because we've made an extra 10, we have 4 tens, and we need to add 8 tens to that. But remember, if we make 10 tens, we can exchange those for 100. So let's add 8 tens. 1, 2, 3, 4, 5, 6. Now we can exchange before adding 7, 8. So we've made 1 extra 100, which we write above our hundreds place value column, and we have 2 tens, which we write in our answer. Now we have 500s because we made this 100 by adding our tens, so we need to add 900s. We can add 1, 2, 3, 4, 5. Now, because we have 10 hundreds, we can exchange before adding 6, 7, 8, 9. So that leaves us with 400 counters, so we have 4 as the hundreds digit of our answer. By adding our hundreds, we made another 1,000, and we're not adding any thousands, so we can just write the 6,000s that we have in our answer. Then we had 9 10,000s, and we needed to add 9 10,000s. But remember, once we've got 10 10,000s, we can exchange those 10 10,000s for 100,000. So then, if we add another 8 10,000s, that gives us 100,000 and 8 10,000s, and that's why we have a 1 as our 100,000s digit and an 8 as our 10,000s digit. Then we had 833,560, which we can see represented here. We weren't adding any ones, and we didn't have any ones in our number to start with, so the 0 in our ones stayed the same. Then we had 6 tens, and we were adding 5 tens. We can add 1, 2, 3, 4, exchange, and then add our 5th 10. So we made 1 extra 100, and we have 110, so that's 1 in the tens digit of our answer. So now we have 6 hundredths because we made 100 by adding our tens, but we need to add another 6 hundredths. We can add 1, 2, 3, 4, exchange, then add 5, 6. So we have 2 as our hundredths digit, and we write 1 above the next place value column along, so above our thousands, because we've made 1 extra thousand by adding our hundreds. Now we need to add 7 thousands, so we can add 1, 2, 3, 4, 5, 6, exchange, and then add our 7th thousand. Then we needed to add 6 10,000s, so we can add 1, 2, 3, 4, 5, 6, and because we now have 10 10,000s, we can exchange those for 1 extra 100,000. So now we don't need to add any 100,000s, but we can see the place value counters we now have show our answer. We have 9 100,000s, no 10,000s, 1,000, 2 hundredths, 1 10, and no ones. Now, our last question was 572,749, which we have represented here. And first, we needed to add 8 ones. We can add 1, exchange, then add 2, 3, 4, 5, 6, 7, 8. So we have 7 ones in our answer. Now, because we made an extra 10 by adding our ones, we have 5 tens, and we need to add 5 more tens. So let's add 1, 2, 3, 4, 5 tens. But now, because we have 10 tens altogether, we exchange those tens for 100. And that's why we write 1 above our hundreds column, and we have 0 as the tens digit of our answer, because now that we've exchanged, we don't have any tens. Then, onto our hundreds column, we have the 100 that we made from adding our tens, and 7 hundredths in the number that we started with. We need to add another 7 hundredths. We can add 1, 2, exchange, then add 3, 4, 5, 6, 7. That leaves us with 5 hundredths in our answer. We need to add 1 more 1,000 to give us 4 thousands altogether. And now we need to add 3 10,000s. When we add 1, 2, 3 10,000s, that gives us 10 10,000s altogether, which we need to exchange for 1 more 100,000. So now, because we don't have any 10,000 counters after exchanging, we have 0 as our 10,000s digit. So now we just need to add 2 more 100,000s to give us 8 as the 100,000s digit as of our answer, 804,507. Now we have some missing digit column addition problems, and we can find our missing digits by working through the problem in the same steps that we use for column addition. So that's working from right to left, starting with our ones. So here we have 4 plus something, and we have an 8 as the ones digit of our answer. Now 4 plus 4 is 8, because 8 minus 4 is 4, so that's our first missing number. But now, when we move on to our tens column, we have something plus 5, but we only have a 3 in our answer. So here, they haven't added to make 3. They must have added to make 13, and then written the first digit, so written 1, above the next place value column along. Now 8 plus 5 is 13, because 13 minus 5 is 8. So our missing digit here must be an 8. Now we have 1 plus 7 plus 3. That's 11, so 1, 1. And now we have 1 plus something plus 6, but we only have a 3 in our answer. So again, they must have made 13 and then written the first digit above the next place value column along. So our missing digit here is a 6, because 1 plus 6 plus 6 is 13. So now 1 plus 3 plus 2 is 6, and then 8 plus nothing is 8. So let's move on to this problem here. We have something plus 8, but we only have a 7 as the ones digit of our answer. So we know that they haven't added to make 7. They must have added to make 17, and then written the 1 above the tens column. So we need to do the same. Now 9 plus 8 is 17, because 17 minus 8 is 9. Now onto our tens, we have 1 plus 4 plus 5. That's 10, so 1, 0. And now onto our hundreds, 1 plus 7 is 8. And then something has been added to give us a 5 as our hundreds digit of our answer. But they haven't added to make 5. They must have added to make 15 and then written 1 above the thousands column. Now 1 plus 7 plus 7 is 15, because 15 minus 8 is 7. So now onto our thousands, 1 plus 2 plus 1 is 4, 7 plus 3 is 10, so that's 1, 0, and it's important that we write the 1 above the next place value column along, because now we have 1 plus 5 plus something, and 8 as the hundred thousands digit of our answer. So 1 plus 5 is 6, and then 6 plus 2 is 8, so our last missing digit is a 2. Now we need to add to a negative number, and for these questions our answer will be positive. And we know that because if we ignore the negative signs for a moment, 5 is larger than 2, 8 is larger than 4, and 9 is larger than 3. So first we have minus 2 plus 5. So on a number line we can start at minus 2 and then count 1, 2, 3, 4, 5, and that takes us to 3. Now we could also count by jumping to 0 and then jumping the rest. So from minus 2, we need 2 more, we need to add 2 to get to 0. But then because we want to add 5 altogether, if we've added 2, we need to add another 3. And 0 plus 3 is 3, so that's our answer. Also notice 5 minus 2 is 3. So if we switch the question around, we'll get the same answer. Now we have minus 4 plus 8. So we could start at minus 4 and then count on 1, 2, 3, 4, 5, 6, 7, 8. That takes us to 4, so that's our answer. Or we could have counted more quickly by first adding to get to 0, and minus 4 plus 4 is 0, but then because we've added 4 and we want to add 8 altogether, we need to add another 4, and 0 plus 4 is 4. And again, notice 8 minus 4 gives us the same answer as minus 4 plus 8. So now we have minus 3 plus 9. We could start on minus 3 and then count on 1, 2, 3, 4, 5, 6, 7, 8, 9. That takes us to 6, so that's our answer. Or from minus 3, we could add 3 to get to 0, and then add another 6, because if we add 3 and then add 6, we've added 9 altogether. And again, 9 minus 3 gives us the same answer as minus 3 plus 9. Now we need to count in steps from negative numbers. So first we start on minus 8, then minus 6, minus 4, minus 2, 0, 2, 4, 6, 8, 10. So here we were adding 2 each time. Now for this sequence we start on 7, then we have 5, 3, 1, minus 1, minus 3, minus 5, minus 7, minus 9, and minus 11. So here we were subtracting 2 each time. Now we have minus 11, minus 8, minus 5, minus 2, 1, 4, 7, 10, 13. So here we were adding 3 each time. Now we need to add to a negative number. First, we have minus 34 plus 69. We can show the addition on a number line. From minus 34, we can add 34 to get to 0. Then, from 0, we can add another 35 to get to 35. So, because we added 34 and then added 35, we added 69 altogether, because 34 plus 35 is 69. Now what we could have done here is work out 69 minus 34. 9 minus 4 is 5, and 6 minus 3 is 3. So that gives us our answer 35. Because when we've already added 34 to get to 0, subtracting 34 gives us the number that we need to add on our next jump. Now we have minus 3 plus 83. So from minus 3, we can add 3 to get to 0. But because we want to add 83, we need to add another 80, and 0 plus 80 is 80. Now again, what we could have done here is work out 83 minus 3. That's 80, so that's our answer. Now we have minus 89 plus 52. So for this question, our answer is going to be a negative number, and that's because 52 is less than 89. So from 89, adding 52 will take us to minus 37. Now what we can do to answer this question is work out 89 minus 52. 9 minus 2 is 7, and 8 minus 5 is 3. But because 52 is less than 89, we need to write a negative sign in front of our number. So our answer is minus 37. Notice 35 is the answer to 69 minus 34. 80 is the answer to 83 minus 3. And though we've not shown it here, minus 37 is the answer to 52 minus 89. We did 89 minus 52 and put a negative sign in front of our answer because we saw that 52 was less than 89, so we knew that our answer would be negative.